camera here. Now you should see my slides. And three dots my video. You can click the pin here for fifth frame. Where you get this entire presentation. Just that at TNT and the fit screen. And then, yeah, just shoot any questions in the chat as we go, or also just raise your hand and we can stop away. Bad, broken, better the sound. Maybe we could try to hook up a different phone in the back here. Oh, sure. Better with here. Oh, bro. It's just sound. Could get that the other one where we have key on the computer. Just start slowly here. We had all. Yeah. Hello, can you hear me? Sure. It's like no information on the bar, but is it? Okay. If you guys can hear me now, I'll try to continue. Is it fine? Just good sound now. Clear but weak. So maybe you need to be louder. Much better now. Okay. Let's see. So yeah, welcome to this introduction course. This is a short run through of all our hardware products here at Blueye. I'll also go through some of the software and see how what our solution is bringing. To start off, we have two different ROVs. So we have the Blueye X1, which is the lighter version, and then we have the X3, which is the more capable version that has 3 guest ports, so you can have more payloads and do more things with it. The X1 only has 1 guest port, which is nice if you just need a gripper or a GPS or similar, or just an external camera. We also had these units earlier. The Blueye Pioneer was the first one we started with, and then we continued with the Blueye Pro. Cool. Just check if it's possible to get this. Yes, okay. So the way the system is working is that we have the Blueye ROV in the water here. So that's where the camera sits at the top and the light at the bottom, and then you get the video signal through this tether up to the tether and the reel and the surface unit. Inside the reel, the surface unit is basically a wireless Wi-Fi, which is battery powered as well. Then you can connect to this Wi-Fi with your Android or Apple device. And we also have other options with more rugged controllers, etc. And then you could use either Xbox controller that you also connect with the Bluetooth to that device, or you can also connect a Mac M1 or later and run the entire app directly on the computer as well. It's also possible to join with the secondary screens if you need multiple screens for more people watching the stream. We'll come back to the observer later. Some technical details about the drones. So we have a full HD camera that can tilt up and down. At the bottom, we have a powerful light. So that's down here. And at the back, that's where the tether is connected. Back here. So we have a very thin tether to minimize the drag, which allows us to dive very deep, even though it's a very small unit. The total weight is less than 9 kilos, and it's about 3 knots forward speed. So that's why we have this very hydrodynamically shaped vehicle. It's also optimized for bottom diving, so if you get close to the seabed, you will get less sediments getting pulled into the thruster, which again would cause more artifacts coming down in front of the camera. The depth rating is 305 meters. It can also be increased to 500 meters if you replace the buoyancy at the top and also the pressure sensor. And of course, you then need also a longer tether to go to that depth. The design is something called a self-stabilizing design. So it's very light at the top, and then we have all the weights at the bottom, like the battery and the heavy things. This makes it always stand upright in the water and keeps it very stable. In addition to that, we also have added these fins that will dampen the roll motion, so you get a natural, stable video. And here is an illustration of that static stability, which is basically the separation of buoyancy and center of gravity, and the fins that are also counteracting the roll motions. It can move up and down, forward, backwards. It can turn around with the aft thrusters, and it can also go straight sideways by compensating with all 3 thrusters. In the app, you can also easily always go to the menu and see what are the controls again. And this will also dynamically update as you change the payloads, or if you have a different controller. If you have the rugged controller, which is the larger one, this will also automatically update itself. So you can see an illustration of your controller. It's also possible to change like the configuration of the up and down if you want to invert the vertical axis, and you can also change some other options to swap between the heave and forward, backwards, etc. We also have some auto modes called auto depth and auto heading. So those help you keep the depth and the direction you're going automatically, and it always continues to update as you go. And then we also have some other auto features as you add more payloads, such as the DVL or a positioning sensor, then you can get station keeping and go to waypoint and autopilot, go to depth, etc. Yeah, so both the X3 and the X1 has these guest ports. So the guest ports is basically to connect external payloads. So these connectors is a connector we developed here at Blueye. It's a smart connector that is able to combine 8 different communication protocols into one common interface. So here we can connect the Ethernet device, RS-232, I2C, PVM, UART, RS-232, 485, etc. And the USB camera. You can also get different voltage levels. So all of these protocols opens up to connect a wide range of payloads in a common way. And then another thing that is very convenient is that we have this little chip in the connector that we can flash with information. So as soon as you plug in a new sensor, the system will automatically detect the sensor and start the required drivers and communicate to the app that now there's a DVL connected, for instance. So everything is automatically configured, so there's no need to do any baud rates or IP addresses or configuration, COM ports, etc. Yeah, we talked about the blind plugs. So a blind plug is basically what you put into the guest port when you do not have any equipment installed, because we need to make sure the drone is sealed. So the blind plug is basically just an empty payload that you put in, and then the drone will read that all the ports are sealed, and then you can dive. If one of the blind plugs are missing, you will get a notification in the app that your drone is most likely leaking. So don't dive. And it's also important to not tighten these screws too much, like finger tight with the short end is more than enough with these Bracos, because the more you tighten it, you just simply squeeze and deform the plastic, and potentially you can create cracks that goes into the O-ring groove, etc. So, and the screw doesn't really hold any pressure or it doesn't have like any mechanical function other than just keeping them in place, because the O-rings are radial seals, so it's sealed out perpendicular to the screw. Our units can be used with 2 different batteries. So we have the Blueye travel battery, which is the standard battery of 96 watt hours. So this is below the 100 watt hour limit for bringing your batteries on as a carry-on on an airplane. And then we also have the high capacity battery, which is more than twice the capacity. So it's 212 watt hours. And then the benefit is that you can operate for much longer, approximately 5 hours. Of course, it depends on your trust. But the downside is that you cannot take it on the plane, and also when shipping these batteries, it has to go on a truck and land vehicles, or not by air at least. And yeah, of course, all our batteries are CE certified and very well tested when it comes to safety and transportation vibration tests, all kinds of short tests. And we have thermal shutdowns and all the things that you would typically expect from a smart battery. We also have like extensive diagnosis on the batteries, which is logged to the dive log, so we can also see if there are any problems with the cells, etc. Then we have the Blueye charger. So of course the charger is not waterproof, even though the drone is waterproof. So, and you see here there are like big holes for letting air through. So make sure you don't charge it outside or and it's also charged in a dry environment. Other than that, you simply plug this gray Hitachi or Belkin. It's basically the USB-C power adapter. Plug it into the wall, and then you plug the USB cable into the charger, and then the charger can either be plugged directly into the drone, or you can take out the battery from the ROV and then plug if you remove this rubber lid, you can then put the battery directly to the charger. And then it's important to remember that on the other side of this, on the bottom side, there's a small switch that you move from the drone or the battery. And if you have it in the wrong placement, it simply won't charge. So make sure that you have it on the right icon and that it lights up here with a solid light. So it's actually charging. So this is the power adapter. So the important thing here is to make sure that you use the top one for the drone, because this is the only port with the 90 watts. The other ones are weaker, so they can be used for other accessories. So your tablet or phone, and then you can use the USB-A ports for the Surface unit and the Xbox controllers, for instance. But just make sure that you use the powerful one for the drone, because otherwise it will take forever. Nice. Here's a small Norwegian title. This is the Blueye Surface unit. Also has USB-C charging, and it's also data over this port, so you can connect a USB-C to Ethernet adapter if you want to have a wide connection and simply connect to the network with a cable. There are two small batteries inside, so these can be charged through the USB-C charging port. And we also have the internals, the antennas on the inside. So there's no antennas sticking out that can break off, etc. So this is also waterproof, but still make sure that you put the rubber lid on to make sure that you don't get the water inside the connector and dust and stuff. Tether and reels. So this is the Blueye reel. You can simply undo the 3 screws to take off the cover, and then you simply place the Surface unit inside. This is typically installed from us when you get it, but if you need to replace it, it's quite easy as well. And then you can choose a wide range of different lengths, up to 300 meters. The standard is 150. Then you go for 250 as well. And the tether itself is a 28 AVG twisted copper cable with a Kevlar core to make it stronger in strain. And you can lift approximately 100 kilos with the cable. So this allows us to also lower the drone by just using the tether. So another important thing when it comes to braking strength is that it's when you're lowering it down, it's important to get a good grip, so you also kind of get forces into the core with the Kevlar, because if you just brake on the outer jacket, you will stretch the outer jacket and not get the forces into the Kevlar, and then you will end up stretching the foam, and you will get like almost like a telephone cord, which is it's not a problem, but it doesn't look very good. Yeah, we talked about the other option for or controlling it. So this is the Blueye rugged controller, which is basically an external controller that has a tablet 5 inside, Samsung Galaxy Tab Active 5. So this is a very rugged and compact solution if you want something more rugged in the field. So this is what most professional customers goes for, but it also works perfectly fine with the Xbox controller and some other tablet. Some people like the joysticks on one or the other better, and so it's a bit like personal feelings as well. And it's also possible to get a fully wired setup here with the Ethernet cable coming straight into a small, they call the backpack on this one. Or you can also use the USB-C port. It can also be charged while you use it, etc. If you go for the Xbox controller option, then you can put the phone on this holder, so you have everything in your hands as well. This is also a very light and simple setup, and also good in terms of redundancy. It's usually quite easy to find an Xbox controller somewhere close by. You can also use the PlayStation controllers if it works with your iPhone as well. So that's just a Bluetooth controller basically. All right. So now we've gone through most of our hardware. So we have the Blueye underwater drones. We have the Xbox controller, the Blueye smart batteries, and the charger, the servers in it, the Blueye reel and tether. We also have some custom tethers for underwater reeling, and like the entire system is fully submerged, etc. But this is the standard option. We also have slip rings if you need a wired connection with the slip ring. And the smart connectors we talked about. So do you guys have any questions when it comes to the hardware? I don't know if everyone is forced muted any still better. If you want to say something and you are not able to, then you can just type in the chat, of course. And we'll see if and raise the hand, of course. All right, I think I'll just carry on then. Now we'll go through some more of the software stack. We'll look at the user interface of the Blueye app, different control buttons and functions and modes, how to calibrate the compass, some Blueye surface unit settings, how the updating the drone works, and some other features as well. So just to give you an overview of the software we develop here at Blueye, we have the Blueye main app, which is like main app you use for controlling the drone and yeah, transferring photos, everything. That's the main app. And then we have the Blueye Observer app, which is a very lightweight app only used for looking at the video on a secondary device. And you can also get a better experience with the guestboard camera in this app as well. And both these apps are available both on the Google Play Store and the Apple App Store. And previously we had this app called the Blueye File Transfer, which was used for transferring files from your drone to the computer or Mac, Windows or Mac. But now we have discontinued this file transfer app and then created a new solution, which is basically the BlueNux web app, which is then a web application hosted on the ROV itself. So you will simply just type in the IP address of the ROV, and then you will be able to browse all both the log files and the videos and the photos and download them directly from the drone. So you don't need any software on your computer to get the images directly. So this simplifies a lot when it comes to large companies with IT policies, etc. So that's a great improvement. So if you start with the Blueye app, so this is like the main way of controlling the drone. It automatically connects to the ROV if it's on the same network, so the Wi-Fi network in the tether reel. And if you have connected your Xbox controller with Bluetooth, it will automatically detect that. And you'll also get feedback from both the drone and the surface unit about the battery percentage here. So it's 48 on the drone and 36 on the surface unit. It'll also show you if it's connected and what version of the app you're running and the version of the software on the ROV. So that's what we call BlueNux. And you also get the name of the unit that you're running on. So this could be good information if you have any problems and we need to know what software you're running. And this app also works on M1 or M2 Mac processors, which means you can just download the app from the App Store on your Mac as well. Then you can connect an Xbox controller to your Mac through Bluetooth as well. Then you'll get a larger screen, etc. Okay, so when you hit start dive, so this is like the splash screen, and you hit start diving, you'll get into the diving interface. So you'll get like a 3D model of the orientation of the drone. So you'll show you the roll and pitch, which could be a good indicator of external forces. So if you see the drone is standing very much down like that, you know that the tether is either caught up in something or that you need simply to pull out more tether. And if it's done like that, then you're typically hitting the ground or maybe stuck with the tether at the ground, so you cannot go up, etc. So it's a very good indication on what's going on, or if you grab something that is really heavy, it will also pitch itself like that. So it's a good sensor to kind of get more information. On the Android app, it's slightly different because we don't have the 3D model there. So it's basically just a 2D representation. One icon showing the drone from the aft, showing the roll, and then there's another icon showing the pitch. The one rolling and the other one pitching. And next we have the heading bar. So it's basically telling you which direction you're going by using the magnetic compass. So just make sure that you are not very close to magnetic interference because it is a magnetic compass. So it can be off if you're close to large magnetic steel structures, etc. And then on the top right, you have the menu icon, this hamburger menu. You click that, then you will get into all the options for video camera and subtitles and navigation, the map, all the payloads, multi-beams, etc. So that's where you open the menu. Here you can see the tilt, indicating if you're tilting the camera up or down, or in the center, or anything in between. You can also tap the center of the screen to get into the touch interface, and then you will be able to both control the ROV with your thumbs, and you can tilt the camera and move the light up and down. Yeah, this is the touch interface. So here you'll get the tilt slider and the boost and slow, which is basically increasing all the gains or decreasing them. So it becomes more faster or slower to drive. And here's the depth indication. And if you have an altimeter or a DVL, you will also get the altitude below this. And then these 4 buttons are start, stop recording, take a picture, auto heading, and auto depth. If you click the menu, you'll get into this. And here you can, navigation is where you'll find the map. Lights, you can tune the external light and internal light. Camera settings can be exposure, hue, FPS, etc. And then external camera, if you have the external camera connected, this will also come up automatically. You can also swap between which camera is the larger one per screen. And then you have video overlay and diagnostics. So video overlay is basically if you want to burn in all these black boxes. So we'll come back to that later. The other app we talked about was the Observer app. So the Blueye Observer app is a lightweight companion to the full Blueye app. It's basically just a simple way to be able to look at the video stream and also some the telemetry data with the depth and the heading, and if the lights are on and the control modes, and also you can take pictures from here as well. So this can be great if you have like one observer that is just looking at the video during the inspection, and then the other guy is controlling the drone, for instance. And then we have the new Bluenux web app, which is just a web page hosted on the drone. So you just go to the IP address of the drone and click enter. And we'll go into this, and then you can see like the most recent pictures and all your dives. Also what kind of payloads that are connected, how much data storage you have left, and video storage. Very soon we also get support for external storage if you need external storage capability with an SD card or USB stick actually. Then that will come up there as well. Another thing you can do very easily is to simply join a Teams meeting on your either the controlling device or the observing device, and then you simply hit share screen, and then like we're doing today, and then you can basically very simply stream the situation to a team of experts, for instance, which can be located anywhere in the world, right? So, and it's also very easy to both get communication with sound and the video, and you can also record a meeting to see what decisions were made or later. But in general, I would recommend running this on a secondary device. So, because if you run it on everything on one device, it can be a bit many things for the operator to pay attention to, the controlling the ROV, jumping between apps, and make sure that you can do everything, but it's fully possible, of course. And also make sure that you turn on do not disturb so you don't get phone calls coming in, etc. All right, so any questions to the software? Just raise a hand or stop me as you like. Otherwise, I'll carry on with external equipment. So we have a wide range of different payloads. We have sonars. These are basically using acoustic sound underwater to draw an image of what's in front of you. So the top left is basically what we call a forward-looking sonar. So this has a fan of sound beams coming out, 512 beams, and the range can be all the way up to 120 meters. And then you'll get a clear picture of what's at the seabed in front of you. We also have these polar scanning sonars, which is a bit more simple and more affordable, of course, but they can also give you a good indication on where you are in a relation to some structure, for instance. We also have side scan sonars that are made for going forward and draw like a larger map of what's around you. So lots of different sonars and also a smaller one that we'll come back to. For navigation and positioning, we have a wide range of different positioning sensors, ranging from DVLs to USBLs and also our own GPS, which is connected on the unit itself. So there are many ways of getting a position estimate of where the ROV is. We also have some other sensors. As you briefly talked about in the introduction, on the wind farms you have these anodes, and basically all subsea structures need some kind of anodes to protect themselves from corrosion. And then we can use different sensors to monitor the state of this system. So the picture here is a thickness gauge to measure the steel plate thickness. But we also have CP probes to measure the cathodic potential, etc. There are also other sensors for water quality, pH, salinity, etc. Grippers. We have two different grippers, the Newton gripper and the Reach Alpha gripper. They are slightly different, but the Reach Alpha is a bit more advanced since it can rotate and open and close a bit wider, while the Newton is simpler and also very good gripper. Then we have our own external camera, which can be mounted both on top and at the bottom in different directions or straight down to make it possible to look wherever you need. And external lights as well. You get light in the same direction, for instance. We can also have two lights on one guest port, which means if you just need a lot of light, you can actually get 6 lights connected at the same time. Then you don't have any other payloads. Yeah, these are the guest ports we talked about. Blind plugs when you're not diving. And as soon as you plug the blind plug, you get the information of what's connected. So here's an example how it looks in the app. There's a Reach Alpha gripper. It can go to 300 meters depth. The manufacturer and also the serial number is visible here. This is nice to see what's connected without having to open it, for instance, and just to make sure that it's actually working as it should. You can also have the Blueye light and camera combo. So these can be connected into one guest port. Then you can have them connected like this. It's basically GoPro interface that can be modified to different lengths and extensions. Yeah, and when you have the external camera, you can use the Blueye Observer app to get what we call the picture-in-picture view. You can also have them quite large side by side if you just put it in portrait mode. You can also swap between which picture is the larger one. Back to positioning systems. The most common one is the DVL from Waterlinked, which is the world's smallest Doppler velocity log. It's mounted underneath like that. And this enables station keeping in auto altitude and also dead reckoning from a known starting point. The way the DVL works is that it's sending out acoustic beams in 4 directions, and then it will measure how the sound come back. And if the vehicle is moving towards the sound waves, they can measure the change in what we call the phase shift. And this can be used to estimate the velocity of the unit above the ground, for instance. It's a very powerful sensor and very commonly used in underwater navigation. Other systems are either the UGPS from Waterlinked or a USBL system that can be used. It works the very similar way. You have like a known fixed point top side and also the heading of this antenna. And then you just measure the distance to the ROV and which direction it's coming from. And then you can calculate the offset and get a global position for the ROV as well. So we have a lot more acoustic positioning systems as well. And we can also take just an NMEA sentence as input on the network, and then we can connect to whatever system you have, such as Kongsberg or Sonardyne or the advanced ones as well. The Blueye GPS antenna can be mounted in the front here as well. So that's basically a way to get the position as soon as you break the surface. And this way you know exactly where you are before you start diving, so you can go to a target coordinate and then just go straight down, and then it's typically much easier to find what you're looking for. It can also be used in combination with the DVL to simplify the way of resetting the starting point for the dead reckoning of the DVL. This can go automatically. And it's also possible to go to waypoints automatically with the mission planner, also with just the GPS. Yeah, and with the DVL, you get something called station keeping, because when you can measure the speed above the ground, you can also control it with a feedback loop to make sure the speed goes to 0, and then you're by definition standing still. So that's how we can automatically fight the current in a river, for instance. We also get the distance to the seabed with this sensor, so then we can add the feedback loop on the altitude to maintain a desired altitude. So here you can see altitude is 1.6 meters, and then it will just follow 1.6 meters as we travel forwards and make sure that we follow the terrain instead of the depth sensor. To activate station keeping, you just tap 2 times on the auto heading button. And then the third time you will disable everything and go back to manual heading. Then there's no auto mode. The same goes for the auto altitude. First you get auto depth, and then altitude, and then disable everything. And with the DVL, you can also start doing mission planning. So you basically create a bunch of waypoints, and then you can use these points of interest as instructions in the mission. And then it will run, show you this green line, which is basically the mission. And then when you hit play, it will start following the points. You can also do like take pictures every 10 meters or go to a certain altitude or depth, go to surface, seabed, etc. So that's this can be very powerful together with other sensors such as the Aquatrol for taking water samples or like the water quality parameters such as pH and salinity, etc. We also have scaling lasers. So these are just parallel lasers to give you an indication of the size of what you're looking at. And then you know if it's 10 centimeters between those, you know in the picture that there are always 10 centimeters between those two dots. You have an altimeter for showing the distance to something in front of you or the distance to the seabed. This is a very simple way to get the auto altitude. We have 3D 360 scanning sonars. Also like a low budget way to get a picture of your surroundings. This is a more rugged version of the same thing. We have multi-beams. This is a very small, compact, forward-facing multi-beam, which has a very low drag factor, so it doesn't really influence the hydrodynamic performance. But of course, it's not as high resolution and not the same range either, with only 50 meters and 90 degrees versus the Oculus, which has 120 degrees, 130 degrees, and 120 meter range. This is far more capable, but of course it also adds a lot more drag to the vehicle. This also comes in different frequencies, depending on your needs. So it goes comes also in versions up to 3000 hertz, kilohertz, 3 megahertz. Yeah, so if you have one of the sonars on the Blueye, you can see it directly in the Blueye app. You can also choose if you want it to be the large picture or a smaller one by just tapping it. You can also do measurements. How far is it to this point, or how far is it between 2 points in the picture? So that's super powerful for doing all kinds of inspection work, basically. It's also possible to not use the Blueye sonar viewer, but use the Oculus multi-beam sonar viewer. which is called viewpoint. And then you can do recording and playback and measurements, export the video in here instead. So it's a bit up to you if you want to use the integrated software or the Windows application. We have pipe profiling sonar if you want to take like the cross section of a tunnel. And then you can use a DVL to measure how far you've gone into the tunnel. Then you can also get like a 3D point cloud of the entire tunnel. We have a Newton sediment sampler if you need to take samples of the seabed. Different grippers with different end effectors depending on what you want to grab or cut the rope. We have the UT gauge to measure steel plate thickness. You can also change the type of steel and the speed of sound in your material in the app, and everything is automatically logged to the log file, so you know exactly what time you measured what as you go. And yeah, here you can see you can choose between a list of different steel types, or you can also put in like a custom thickness if you want that, or custom material. And you can also get the measurements on the video recording as one of these black labels showing you the measurements as you go. You can also change the title and subtitle to know which part you're measuring. Aquatrol is a multi-parameter sonde. So this can carry up to 4 different sensors at the same time. And then they have 14 different types of sensors that you can put in there. And all of this is very well integrated into the Blueye app as well. So you can right away look at the data and see if you're getting the measurements that you are expecting. And if you're at the right location, and just to make sure that you're actually sampling the right thing. This can also very easily be exported to Excel or CSV for further processing in Python or what you would like. This is the CP probe, which can be used for the anodes. So it looks similar to the thickness gauge, but you simply just poke into the material and then you'll get a measurement voltage in the display directly in the app as well. Then we have like some crazy sensors for detecting gamma ray underwater. So can be used for like atomic damages, etc., or salvages. Okay. So any questions regarding the payloads? No. So we'll just carry on with the diving part. So before diving, it's always good to download the app and make sure that it's connected to the internet, so you'll get notifications if there are any new updates, and also that you actually have the latest version of the app. And it's also good to connect to the drone network so you know that you have the right passwords, etc. And you can also check for drone updates. And when you connect to the drone, you also get the software version on the drone, and then you will get the option to update it if it's out of date. You can also connect the Blueye controls to make sure that the pairing is faster when you go diving. And it's good to calibrate the compass before you go out. So that's done. Then you can also make sure that you're calibrating in like a neutral environment that doesn't have a magnetic disturbance. Yeah. And then further preparations are thinking about the environment and the conditions of the area that you're going into. Is it going to be a lot of traffic in the area? How can you position yourself so you're higher chance of succeeding? Where is the tether? Is it going to cross the entire inlet to an harbor, for instance? Can you position yourself smarter? Are you going to dive from a boat or from land, or is it a moving structure, or can you stand completely still? We always recommend standing still because it sounds easy that you can just move the boat a little bit and someone can just be controlling the boat, but then you have so many moving factors. You have current in the water and you have wind at the surface and tether in the water, and you can very easily end up with a tether in the propeller, for instance. And then it's can become quite chaotic. And so if you can find a stable platform, that's the best, or you can anchor, or you can, we also use these GPS anchors, which is a very small propeller in the front of the boat, which can a digital anchor. So you can basically keep your position even if there's great water depths. And you can also try to think through how are the currents going to be and the waves. Are there any forecasts that you see are correct? And are there times of the day where the tide is maybe better or less current? Maybe also trying to keep track of these conditions from last time you dove, so you can know what to expect. If there is significant wave height of 2 meters, then you kind of know in your head that, okay, that's going to be this much hassle today. And also the visibility greatly changes with the, it's raining a lot, you typically get poor visibility. So that can also be kind of planned if you look into the forecast. And in general, visibility is much better in the winter time because of less algae and blooming. When it comes to weather and being comfortable, it's important to try to find a way to shelter from the rain. You also get less sun glare on your screens and be able to sit comfortably because most of the time it always takes longer than you first expect. So it's good to sit in a nice chair. Also bring enough batteries so it's possible to have some extra capacity if you need to stay longer. And also good to try to return before you're completely empty, in case you got stuck somewhere with a tether and you didn't see it, for instance. Yeah, this is a long checklist, but it's basically easier to just look at when you have the ROV in front of you. But it's basically just make sure that you can power on the unit and that you can run the thrusters, and yeah, then it's basically Yeah, this is back to the charging, the little switch I talked about. That's indicated here at the bottom. So it can be either charged directly to the drone or with the battery directly to the charger. Benefit of this is that you can have multiple batteries, and then you can also be charging while you're operating, for instance. As I said, 90 watt for the drones. The other ones doesn't really matter. Some general tips for saving battery is, of course, to use as little boost as possible, because this is a very non-linear relationship between the force you get and how much energy you use. So if you manage to move slower, you will have a much longer runtime. But sometimes you need the boost to be able to stay against the current, etc. But if you just drive around fast because it's fun, then you'll also burn more battery, of course. The same goes for just diving down. You can also go more efficient if you go a bit slower. So the normal mode, when you do not boost, is very efficient and still quite fast. But with boosting, you basically just burn a lot of energy. And here it's also advised to try to return when you have 20% left, because then you have some capacity to get home. Before you go diving, you can also go and download the map of the area that you're planning to go. So this is our offline map. So if you just go to the settings tab and then find the map settings, you can simply just scroll over to the area that you're inspecting and then hit select the map that you want to use and then click download map. And now it will automatically download all the tiles at the different zoom levels for this area. So this is a very nice way to get the map also when you're not connected to the internet. Compass calibration, also good to do before going out. You don't have to do it for every dive, but if you're traveling far distances, so more than 10 kilometers away from your last location, or if it hasn't been used for over a month, then it could be good to calibrate the compass, because then you'll get a better calibration. Also, if you change the payloads and basically adding magnetic fields to the unit, it's also good to do the calibration over, because all these small metal parts will have some influence on the magnetic field. So to calibrate the compass, you simply go to settings in the app and hit the drone settings. Then you'll get to this compass calibration. And it will simply show you the 6 progress bars, which are basically showing the status for each axis. So you'll point the drone in different directions like this, and then you'll just rotate 360 degrees in each orientation. And at the end, you will have all 6 bars light up green. Then you click continue, and you have to place it on the ground, and it will run the thrusters to measure the magnetic disturbance from the thrusters. And then you have a new calibration. Then it's also good to verify your calibration when you go into the diving screen, and just see if you can get a nice circle with all the headings from north to south and north again. Okay, so video overlay is also important to check before you start diving, because this is where you can set the title and subtitle and check if it's on. Sorry, almost. So video overlay can be on or off. That's this icon that shows up when you're recording here. If it's on, it's like that. If it's off, it's not there. And then this is where you see your current title and subtitle, and that you cannot see. That's on the left side. Let's see, it's here. Here's the title and subtitle. Yeah, you can also choose a custom logo if you want your own logo, or no logo. And if you have a GPS or a positioning sensor, you can also enable the label to show the position on the labels as well. The good thing here is that you can very easily see, change the title so it reflects what you're looking at in the post-processing. So on the video recording, this is what the video overlay will look like. So you'll have the title and subtitle, and the date and time, the altitude and GPS coordinates. This is actually at Galapagos, quite close to 0 latitude. And then the temperature is here, the heading and the camera angle, and the depth. And if you have a thickness gauge, you will also get a label for the thickness, or a CP probe, you'll get the voltage. And this is where the logo comes. And of course, these black labels are burnt into the video. But it's very important to make sure the title and subtitle is correct, because it's quite difficult to change it afterwards. Any questions to the pre-diving section? Very quiet gang today. Have you had any questions on the chat? Some small ones? That's good. Just let me know if it's too fast or too boring. I'll try to adapt. So now we'll go through some simple training tasks and basically show you how this is done physically. Since you're not here physically today, we have to use some videos. So this is how you start. He just powered on the surface unit first, then he took the magnet to power on the ROV on the light. Then he basically goes into settings and Wi-Fi to connect to the Blueye Wi-Fi. It's the standard password. You can also change that password if you want something else. Make sure that, or just be aware that it's very easy to reset the password to the standard password by just clicking the battery button 6 times. Then it will reset the password. So the security is not in the password, but like physical access to the reel. Now we just connected the Bluetooth controller on the Bluetooth interface. You open the app, sees that is connected to the surface unit and drone, then he clicks start diving. Then you can tilt the camera up and down just to see that you have connection. You can also play with the joysticks to check the thrusters. Now you see how we can lower it into the water by firm grips to get a hold of the core of the Kevlar. That's how you start it. It's very quick to deploy. I think it's less than 2 minutes, which is like very fast. Let's just so if the app is connected to the internet and there's a new update available, you will get this pop-up. It will show you which version you have on the drone and which one is the newer one in the cloud. So this is 3.0.47. Now we're at 4.5 or something. You basically download the update, then this will go down to your device. Then you can change to the Blueye Wi-Fi and then click continue update, and then it will offload this file to the ROV, and then it will run the update automatically and reboot. Yeah, this is how you control it. This is easier to just try out yourself. But of course, you can always find back to these overview in the menu as well. It's always good to start at the surface. Try to get the feel of the different motions and how long does it take for it to turn. How is it different when you were boosting? This was boost. And, so you kind of get the motions of the unit into your muscle memory in a way. And then you dive down and try to use the camera only, because then you'll get a better understanding on which motions to expect. This is how you can do very slow movements. What you call the slow. So you have boost on the right side and slow on the left side. So these can be used for very fine motions to do inspection videos, for instance. Yeah, auto depth and auto heading are those two buttons. We always recommend putting those on as soon as the ROV is in the water. You can enable those, because then it will automatically maintain its depth and maintain the heading. But you can still drive it around like normally, but it will stabilize your inputs. You can also see your current boost or slow setting at the top here. And here are some basic training tasks. So the easiest source of navigation underwater is to look for your tether, because most of the time it's coming back to you. And to find the tether, you typically go upwards and spin around, because the tether is positively buoyant. It will be above you. So go up and then turn, and then you can see it in the camera. And then you follow the tether back, and then you'll see if it's a free tether back to yourself, or if you're stuck onto some debris in the water or similar. Another very nice task is to try to follow a line. And then to get this set up, you can just take a line and tie a piece of rock at the end of it and toss it into the water. Then you'll get like a straight line to follow. You can also play with it at different angles to have it very like slowly going to the surface, or you can have a very steep and tight rope as well. But just trying to have the correct distance and also maintaining the rope in the center of the field of view is a very good exercise, because if you get too far away, you won't see it if it's bad visibility. And if you get too close, you can easily miss the entire rope and drive past it. So you have to have like a nice distance and make sure that you can keep it in the video frame. The same you can do if you find some structures going sideways, typically anchor lines for small boat harbors, etc. Then you can try to do like smooth motions at a constant speed. And as you get more comfortable, you can also try more advanced maneuvers, such as pan across and go around pivot point. And this is very good to get detailed inspection videos, because now you see there's like a very constant sideways motion, and you also see the crack in the front here, that it looks very different from different angles. So here you can't really see the crack, but from this angle you clearly see that there is something broken. This means that getting video from different angles can be very important to understand the full damage. When you get these type of inspection videos, you get like a very good perception. The same you can do for wall inspections or similar. And to get these kind of stable motions, it's important to not play with both thumbs at the same time, but it's better to do some static slow with the touch bar. Then you go full sideways with one thumb, like sideways, and the other one is only used to slightly correct the heading. Because when you have it full down, you know that you have a constant force going to the right. Then you just compensate slightly with one finger, and then you really don't have to think as much either. But if you go with both, you will have some delay, and then you will overshoot, and then you will typically get into like a very wobbly speed and camera. Another classic question we get is that how can I get loose if I get stuck? So try to illustrate that here by diving close to structure. And then you can see in the 3D model, for instance, that there are some motions that are like lagging a bit, or you feel that you're stuck. Then you will simply turn around, find the tether, follow the tether back, and try to understand if I'm below or above, or how is it actually hooked. And then you just go in the opposite direction of what you came, and try to, and also carry on a little bit, a couple meters extra, so you make sure that you take out the slack. But it's very important to, when you get into this scenario, that you don't pull on this end, because if you just pull all the slack from the top, you will pull the ROV into the point of trouble, and then you will have so short line that you cannot actually turn the ROV. And if you can't turn, then you cannot get free either. So it's better to have the slack that you have and turn around and have a look. And then it might be that you can help yourself by pulling here, but at least use the ROV to observe the situation so you know what you're doing. And even better is if you have two ROVs in the water at the same time, then you can ask your buddy to go over and film how bad it is and help each other like that. And when you get even more comfortable, you can also start trying to go into different obstacles. And then you get like a good understanding of how tall am I and how far down is the drone with respect to the camera. And especially if you have the secondary drone to film it from the outside, you will get very good feedback on how you fit into tight spaces. This is what we have done on a lot of very deep plane wrecks in the Trondheimsfjord. So we've been diving inside the cockpit of airplanes at 200 meters plus. So that's always very exciting. And of course, if you have two, you can also use the other one to go back and check if you're stuck and how to maneuver to get back out, etc. And you can help with lighting, and with two drones you can have one unit just being the light source and the other one filming from this angle. Then you can get no backscatter and like super nice images as well. Okay, so let's pretend you now went diving. Any questions regarding the exercises? No? Then we can go to the after dive. So after diving, you basically you can transfer media files and download the images. Then you can turn off the ROV by using the magnet. Then we simply recommend to rinse the drone with the fresh water. So either with a hose or the best is just a big bucket of fresh water that you can just dump it in a couple times. Because then you get water all the way inside as well. And every now and then it's also good to actually open the ROV to have a look inside and to actually clean it off on the inside. And it's important to turn off the Samsung tablet because it's the controller is actually draining a little bit of power as well. And yeah, if you want to leave the batteries for a longer time, you can try to keep it at 40 to 50%. Because then you have the best conditions for storage. You don't want it to be very low because then it can be under voltage, and you don't want it to be completely full because then it's not good for the cells either. And before you place it into the Sargas case, it's important to dry it off and keep the lid open because otherwise it will be very moisty in there, and all the parts that are not waterproof will then have a very high humidity as well, such as the Xbox controller and the charger and whatever else you have in there. So nice to keep it dry first and then put it in the box. And there's no airing in the box there. So when you finish diving, you simply hit the transfer media files And then you will see what you recorded. You just select the files you like. Basically, transfer, and you can just click yes if you want to keep the overlay from when you were diving, or you can say no if you want to take it out, or you can also overwrite it with different titles now. And then you can click sync dive logs. It will download all the dive logs that you don't have on your device already. So if you use your own device and you dive one time, you typically get one log only. And then this is also where you can synchronize dive logs up to the Blueye cloud, so we can do fault analysis, etc. You can also change the comments and titles and stuff on the dive if you want to make it easier to remember what you did. You can also browse the pictures and the videos, and you can look at the depth profile at the bottom there. Then you can also click the share button to export this log file as a PDF or XML or KML. So the KML is a file used for Google Earth to display the position track from the positioning system together with the photos that you captured. And you will see these photos on the map later. You can also get the Excel file or the CSV file or the PDF or Word, which are then different type of files that you can use in your reports. Again, long list of something that is quite short actually. It is just to make you remember all the steps for the first times you're doing it. So yeah, basically transfer files, upload video files, delete the files that you have downloaded, so you keep the drone as clean as possible. Turn off the ROV, turn off the surface unit, turn off the controller, inspect the last meters of the tether, just to check if you have gotten any damage. Control the thrusters that they are free to spin, so you don't have any seedweed or fishing lines, stuff like that. And you can basically just take either a tool like this and try to rotate the thrusters, or you can also run it from the app. And then it's basically to recharge all the batteries. Yeah, when you sync dive logs, this is what the dive tab look like. This is what the dive report looked like, the Word and PDF file. You can also change the template which is used for generating this PDF. If you want your own logo or change the table here slightly or exclude the graph, that's all very easy to do. But the main benefit here is that you very easily get all the pictures from that dive into one document, which you then can continue working on adding new captions and comments. If you have the positioning sensor, then you can get a track like this with the photos on the map. This can also be opened in other positioning software, such as QGIS or ArcGIS, or yeah, a bunch of options. Yeah, another fun fact is that when you change the title or the subtitle, you also automatically get this pin. So this light blue pin with a star is when you change the title to pipe inspection. And then you can use this as an indicator of when you have different sections in the dive, for instance. You can also make 3D photogrammetry models with the third-party software. We have support for exporting IMU data, which is time synchronized with the videos. And this greatly improves the processing time for models. So this is actually the front of an airplane here in the Trondheimsfjord that we did many years ago. We have a bunch more examples online here. We also have the Blueye SDK, which is short for software development kit. So this is basically a very nice package on GitHub to get started with basically accessing the drone from code instead of using our main apps, such as the Blueye and the other software. So with the Blueye SDK, you can control the drone with Python, or you can download all the photos automatically, or you can just tap into the control signals and look at them live if you want to learn more about how a robot is working, basically. So this is mostly used by universities and PhDs and researchers. Universities. Any questions regarding that post-processing? Post-diving? No? All right. So then I thought we can go through some of the support, how you can help yourself and how you can get help from us. So all our support tickets comes into our front end, which is like a ticketing system, and then it will be distributed out to the engineers who actually made the product. So if it's a camera problem, it goes to the camera engineer. If it's a positioning system, it comes to me. And if it's a mechanical question, we'll get it to the mechanical team. So it's very close to the source of the problem. And everything is in-house here in Trondheim, in Norway. And of course, for us to be able to help you as good as possible, it's always important to include a screenshot of the diagnostics page. So that's at the bottom of the menu that we saw in the app. And this will include all the information of the software and the payloads connected, and if you have any error flags, and yeah, just to basically give us a good overview of your situation. Yeah, and you'll typically get a reply within 24 hours, and you will be satisfied. And we also have a very large library of different help center articles, and it's also free of charge. I can show you guys how this looks. The help center is basically just go to support.blueye.no, and then you just Google DVL, for instance. and you'll get different articles regarding the DVL. And we can have a look at this one, and you see a short introduction to the sensor, a video maybe, where it can be connected, what it looks like, what's in the box, the steps to put it on, how you do the wiring, and what it looks like on the inside. And also, if you need to add buoyancy, you can get tips on that as well. The new control modes it enables. A short GIF showing you station keeping in the river. So going through all the hardware setup and also the how to use it in the map. And we also have some tutorial videos on how to get the best possible positioning estimate, etc. How to use the mission planner. So there's a bunch of different payloads. We have, yeah, a lot of things that you can look at here. And sometimes it's even easier to just go on Google and do like Blueye, Oculus. Then you see here is the support of Blueye for the Oculus. Then you'll come directly to this page. All right. And when it comes to maintenance of the ROV, basically inspect the cover and shells for cracks or damage. And none of the plastic parts are really critical for the watertight compartments, but it's just to make sure it's working as it should. And then you can remove the plastic covers and buoyancy and rinse off every now and then, just to make sure that you get out both yeah, debris that can start smelling and stuff. You can also check that the thruster grids are in place and that they are there. They very rarely come off, but like here, there's this grid here, which is very easy to open if you need to. You basically take you see one finger in here, and then you can lift up. That's how you remove the top grid. And just push it back down. I can also show you guys how to open it, because it gets questions on if it's difficult or if you can damage it. It's very robust plastic, so it takes a lot for it to break. So don't be afraid to apply some force when you open this the first time. So to open it, you basically do the 3 screws, one here and one here. There's one here. And you just grab the back and underneath this little tab. And then you just pick it up and you'll get the, you see it's this tab here that you need to make sure comes loose. This is also very solid plastic. And in the front here you have two hinges. Make sure these enter when you put it on here. Yeah, put it further down like that. And this is the buoyancy part. Very easy to remove. And this is where it makes sense to clean it every now and then, because if you get a lot of old algae and fish food or whatever, it may start smelling if it doesn't really dry out. And it's also very easy to change the payloads with one screw and just pull out. This is the smart connector. We have autofocus today. I don't know. It's here. We have double O-rings on all the connectors. It's very easy to pull them off. Then you can lubricate them and put them back on. And also make sure the groove is cleaned with the Q-tip or similar. And the same goes for the tether connector and the thruster connectors. And also show you the battery canister. So to replace the batteries, you just use this tool, which is the pin spanner. And there's a spring to push the battery in. And we have the double O-rings here as well. But if you want to remove these, you typically put a piece of tape over the threads to make sure it doesn't scratch and damage the O-ring when you take them off, because this is quite sharp. So put some piece of tape and then you just press on each side and you'll see it pop out, and then you can just pull it off like that. Then you lubricate it slightly and put it back on. This is way too much grease. This is a brand new drone, but I think it's a little bit too much. And then you just take out the battery and put in a new one. Now there's no battery in here. Yeah. And of course, make sure not to place this on the ground, so you get a lot of dust and someone walks by and you get sand and stuff in it. So it's good to either keep it in your hand or put it back in, because then you know it's in. Then when you close it, you can go all the way, but then go a quarter turn back, because we want some distance here. Because if it's all the way in, you can get problems with the temperature changes, that the materials are not expanding at the same rate, and then it can be really hard to open. And again, the O-rings are it's a what we call a radial seal, so it's not doesn't need the pressure to stay tight. Then I'll just look at the hinges first, make sure they enter, and then just press here. Oh, the camera went black. Back online. Any questions regarding this part? Yeah, we went through the health center. This is what the diagnostic screen actually looks like. So you'll find it on the menu. This is where you can capture the screenshot. You can also run a self-test if you want to include that. And then it will basically run some inertial or internal checks on the ROV as well. And we also have Blueye service, so you can either book a service on our webpage, then we'll do a full check and inform you if there are like any repairs that are necessary. We can also do like a full electronics replacement if there is a leak, but there are separate products for this. That's it. Do you guys have any questions? No? It's all crystal clear. And the time is 14:01, so it's quite on time. Of course, if you have any more detailed questions, you can always reach out on support@blueye.no, and we will come back to you with the answer as good as we can. Okay. Should we just wrap up then? Yeah. Thank you, guys. Thank you all for joining, and I hope you learned something at least. So see you around next time.
Thanks, Andreas. Cheers.
Thank you, Roberts. I'm glad that you're still awake.